In today's video, we are going to be solving equations with roots and radicals. So square roots, cube roots, anything involving the radical symbol we'll be using at some point in these equations. And a lot of these you'll notice is going to be pretty much very similar to how you've solved equations before, just with one extra step to get rid of a square or a square root. All right, so I have two different equations here. All right, I'm going to solve this first one on the left. So we have x equals the square root of 4 times the square root of 4. So whenever you multiply something by itself, another way to write that is x equals the square root of 4 squared. Okay. Now, think about this. The whole purpose of a square root is the opposite of squaring. So if I take a square root of 4 and then square it, basically I'm undoing itself. So my answer, when I take the square root of 4 squared, it's just like if you're doing the opposite. If you add 1, then subtract 1, you get the original number. Or if you multiply by 2 and divide by 2 from a number, then you get the original number. Same thing here. When you take the square root, then square it, you get the actual original number. So x equals 4. Okay, simple enough to get my answer. Same thing here. How many of these cube roots are there? Cube root of 7 times the cube root of 7 times the cube root of 7. So that is the cube root of 7. Okay, let me fix this. Cube root of 7 cubed. So the cube root and the cube cancel each other out. So now it's just x equals 7. You can only do that, though, when you have the same radicand. So radicand is what's inside of the radical symbol. This is the radical symbol. These need to be the same in order to have it squared or cubed. Okay. So those are my two answers there. Okay. Let's take a look at a little bit more complex problems. All right. So this one, basically what's nice about this one right here, okay, is that x equals, okay, I'm going to bring down to 3. The square root of 25 is a perfect square, right? If I do the square root of 25, that is 5. That is a nice number in the calculator. And just to show and prove, I'll show you 25 is 5. So back to this. The square root of 25 is 5. So I'm going to be multiplying 3 times 5, which is 15. Okay, and that's my final answer. Same thing here, okay. X is -4. I'm going to bring that down. Okay, now I have to find the cube root of 27. That is a perfect cube. So there's such thing as perfect squares, and there is such thing as perfect cubes. What times what is 27? It's 3. And to prove that, I'm going to take the cube root of 27, which is 3. So this is 3, and I have -4 times 3, which is -12. There's my final answer. Okay, so what was nice about these is that this was a perfect square and this was a perfect cube. All right, let's take a look at more examples. All right, these now. With these, you don't see a radical symbol, but what's nice about these are both one-step equations that you could do to solve. So just like we said before, how do you get rid of a square? So if I take a look at this first one, to get rid of a square, you have to take the square root of both sides. So to get rid of the square, you have to take the square root because that's the opposite of squaring. And whenever I do this side, I also have to do this side. Now, when I get my answer, the square root of x, the square root of x squared is just x. You got to be careful when you're solving, though, when you take the square root of both sides. You're going to get a little unique symbol when you solve this, because when I take the square root of 9, you can say, oh, yeah, that's a perfect square. Square root of 9 is 3, right? But you have to be careful when you take the square root of both sides, because the answer could be 3 or it could be -3. Right? Because if I do -3 times -3, it's also going to equal +9. So whenever you take the square root of both sides, you have to take into effect that you're going to have two different answers. You're going to have a +3 and a -3, and there will be symbols you can use if you're using like a digital format, like formative. Okay, you will see this plus or minus symbol. So there's actually two answers to this. It's either +3 or -3. And that's my answer there. Same thing here. I'm going to take the cube root of both sides. Okay, now I don't know this off the top of my head, so I'm going to use my calculator. With the cube root, it's a little different though. You don't get two different answers, and I'll show you an example why later on. Okay, but definitely let's find the cube root of 1331. 11. Okay, so since it's 11, okay, it's only going to equal +11 with the cube root. Okay, because if it was -11, okay, let's say hypothetically, if we could have had -11, we would do, right, -11 times -11 times -11. That's -1331. All right. As opposed to the square, right? If I did -3 times -3, -3 times -3, that's going to be +9. So it's okay when you do the square root, you get two different answers. Cube root is just going to be either positive or negative. So just be aware of that. All right. Let's take a look at another multi-step equation. All right. Now, basically, when you're given a scenario like this, all right, I'm going to draw my line down the equal sign. You're going to approach this just like you would with a two-step equation. So if this wasn't here, pretend like this wasn't here. We have 3x minus 12 equals 36. What would be the first thing you do? You add 12 to both sides, just like a normal two-step equation, right? So you add 12 to both sides. These would cancel, and you would get 3x squared is 48. Okay, and again, pretend this is not there. Divide both sides by 3. 48 divided by 3 is 16. And again, now you get back to just like what you had over here before. Just take the square root of both sides. So with this, you're just going to take the square root of both sides. Do a different color. Let's pick green. So take the square root of both sides. Now remember, when I take the square root of both sides, I get two different answers. I get positive and -4, right? Square root of 16 is either +4 or -4, and that's my final answer. Okay, so same steps as before when you're solving multi-step equations, except you just got to throw in the square root at the end. All right, let's take a look at one more. Oh, yeah. Got the parentheses here. So I'm going to draw my line down the equal sign. Okay. Yeah, so whenever you have parentheses, okay, first thing I'm going to do, I'm going to multiply, right? 4 times 3x cubed. 4 times 3x cubed is 12x cubed. All right. And then we do a different color. We do red. 4 times 6 is positive 24. So plus 24 equals -72. All right. Then, just like how we did before, we just did one extra step. We minus 24 from both sides. So we get, I'm going to bring this down, 12x cubed is negative 96. Divide both sides by 12. I'm just going to double check my math here just so I don't make a mistake. And so we have negative 72 minus 24, negative 96, good there, divided by 12. So I'm going to take my answer, boom, divided by 12, and you get negative 8. All right. So you get x cubed is negative 8. All right. And again, to get rid of a cube, we got to take the cube root. So the cube root of both sides, which is what times what is 8? If I put that in the calculator, negative 8 though, cube root of negative 8. So I know 2 times 2 times 2 is positive 8, but since there's a negative on the inside, it's going to be negative 2. And that is going to be my final answer. Okay, so that's going to be your final answer. So when you take the cube root of both sides, and this 3 is a little messy. There we go. So when you take the cube root of both sides, okay, the cube root of negative 8, if I do that in the calculator, again, cube root of negative 8 is negative 2, just negative 2, one answer when it comes to the cube roots. Okay, so that's it for today's video. Thank you for watching.